Now, take a look at this. This is Typhoon Haiyan from space. Scientists say it was one of the most powerful storms on record to ever make landfall. Joining us to explain the meteorology behind this monster is climatologist David Robinson. He is the New Jersey State climatologist and a professor at Rutgers University, and he joins us via Skype from Piscataway, New Jersey. Thank you so much for being with us, David. We appreciate it.
My pleasure.
Can you sort of explain not only I don't even know the marvel that this storm is? I mean, it's devastating, and so I don't mean to paint it in a positive light, but what came together to create a storm like this?
This was truly a remarkable storm, one of the strongest storms on record. It's not all that uncommon in the Western Pacific to have cyclones that get the super typhoon status, but you just need all the stars to align correctly. You need to have the warm waters below that fire up these storms, that provide the fuel. You need to put a little spin in the atmosphere to get that storm percolating up through it. You need to be able to ventilate the storm. You need to be able to take the rising air and move it away so that you will create this draft and more air will rise. And all the conditions were right in place for this to be a monster storm. And it's been a very active late season in the Western Pacific. And this, we hope, is the exclamation point. And there won't be any more beyond this.
Oh, yeah, we certainly hope so. Now, will we ever know with any certainty the exact details of this storm? As I understand it, there's not a lot of equipment in that area to measure storms like that. So will we ever really know? And how do we know what we know so far?
Well, a lot of what we've learned thus far is from looking at satellite images, as you mentioned earlier. And there's a certain shape to the storm, development of the storm, and there's a scale that gives tropical meteorologists an estimate of the winds. And this storm was just perfectly formed, a perfect situation that gave one the idea that the winds were exceedingly strong. Now, there's a debate amongst different hurricane forecast entities in Japan, in the U.S., and in the Philippines on just how strong the winds were. But put it mildly, the weakest of the estimates put it at about an EF3 tornado status, and the strongest estimates put it almost up to an EF5. In other words, catastrophic destruction in a tornado. And this is something that went on for hours. So this is just remarkable in terms of the intensity of the wind. And then you add to it the storm surge, which might have been 10 or 20 feet above regular high tide level. And it was almost tsunami-like in the way it came ashore and just washed away coastal villages.
David, which was worse, that storm surge or those incredibly high winds?
Likely it was the storm surge. Historically, the storms that have killed thousands, and in some cases over 100,000 people around the world in the past, it's come from the storm surge, not from the wind. Actually, the second most prevalent killer in these storms would be river flooding from rainfall. Now, this storm produced a lot of rain, but it had a forward speed of about 25 miles an hour, and that made the rain cease a little more quickly than it traditionally doesn't with some storms in the Philippines. So this was a case of exceedingly strong winds, but in particular the storm surge that was so deadly.
I know that this is the biggest and the most ferocious storm to ever make landfall, but can you put this storm into perspective for hurricanes that we've seen here in the U.S.?
Yeah, this is probably along the lines of Hurricane Camille in the Gulf of Mexico in 1969. There's some estimates that the winds might have gotten as strong as 190 miles an hour in that storm, with a storm surge exceeding 20 feet. So we've seen a number of storms, the Katrinas. There was a major hurricane in the Florida Keys in the 30s that had a tremendous storm surge. We had the Galveston hurricane in the early 20th century that killed perhaps 8,000 or 10,000 people. So, but in terms of winds and power, Camille is probably the best one to compare to in the United States. Maybe Andrew as well, but Andrew was a smaller storm than this.
Take us to school just a little bit. Tell us what the difference is between a typhoon, a cyclone, a hurricane.
The only difference is where it occurs geographically. They're all the same storm, the same mechanisms, the same meteorology, but they're known as cyclones in the Indian Ocean, to typhoons in the Western Pacific, and hurricanes in the Eastern Pacific and in the Atlantic Basin.
And this is for my own individual curiosity, do they all rotate in the same direction, David?
In the Northern Hemisphere, they rotate counterclockwise, but you can get them down in Australia and that region, and there they'd be rotating clockwise. All depends on the hemisphere in which they occur.
Okay. Let me put you on the spot just a little bit. I know you're here to talk about Typhoon Haiyan, but I know there are a lot of study and analysis has been going on about Superstorm Sandy that, of course, hit the east coast of the U.S. last year. What more have you learned about that you found intriguing?
Well, there's more and more research being done on it. There's more simulations by models. There's manuscripts being written about the storm. And I think we're beginning to appreciate more and more the unique hybrid characteristics of that storm, where you had what we call a warm core storm, a hurricane, that had a mid-latitude nor'easter wrap itself around this storm. And as the two interacted, it actually amplified the power of a waning Sandy hurricane. Made it a little bit.
I got to jump in there, David. I'm so sorry I asked you the question and I should have left enough time for you to answer it, but I do appreciate it. Thank you so much. Take care.
My pleasure.
And thank you for joining us. We'll see you tomorrow on Arise America.